In this video, we're going to take a look at some more parts of circles, specifically the names of different kinds of angles. When we start off on a circle, we always start off where the radius is in this position here. This right here, this red line that I am drawing here, is what we call the initial ray. And the initial ray, you'll notice, basically always starts along the x-axis. And this is because it's the starting position, we see that it's basically at 0 degrees. If you think about a protractor and how you measure the degrees, you'll see that you're on the flat surface there, right? And you want to start at 0 degrees and you work your way up. And so you'll see here that there's 90 degrees and so on. So if you ever recall seeing a protractor, you'll notice that the angle measurement always starts at the bottom right there, okay? So that's called the initial ray. I'm going to go ahead and go in a different color now. And as this ray starts to move up, let's say we create a ray right here. And we stop there. Because we stop there, this is what we call the terminal ray. And if you think about what the word terminate means, to end, this is where we kind of end our angle measurement. So you can see that this angle measurement stops here. We can call this an angle, let's call it theta. When it comes to trigonometry, you're going to find that you use a lot of Greek symbols, and this particular Greek symbol is called theta, okay? Like that. All right, now, because it's a circle, we know that circles are basically endless. There's no corners anywhere, there's no stopping location. So what you can do is imagine that this purple ray that has right now, at the moment, stopped in this position could technically keep going in a circle, just like what you see on a clock on a daily basis. If that keeps going and going and going in a circle, well, we are noticing that we actually are going counterclockwise. And let's say we end up stopping at the exact same position as that purple line. When you end up going all the way around a full circle, this is what we call the coterminal ray. So a coterminal ray is basically where you end up at the exact same position, but you've gone around a full revolution. Okay, so those are going to be the three definitions we're going to need for taking a look at our next few examples. So for example 4, find two angles, one positive and one negative, that are coterminal with a given angle. Okay, and we're going to have to show our work clearly. So first step, part A, 80 degrees. As we take a look at 80 degrees on the unit circle, what I would really recommend is you always draw your coordinate plane, okay? So basically just draw a T, and then we're going to draw 80 degrees. Now based on what I know about angle measurements, I know that 80 degrees is roughly around this location here, right? We're not quite at 90 degrees. We're going to be a little bit less than 90 degrees as we went up from the 0 degree mark, okay? So that's 80 degrees. So if we want to find a positive, I'll color code this. The positive coterminal angles, actually let's do it the other way around. I'm going to make positive blue, and then I'll make the negative red, just because we tend to think as negative going in reverse. It's a negative, like a deficit, right, in terms of money. So I'll just call positive blue and negative red. So if I want to find a positive angle, that must mean that I want to keep going in the same direction and keep adding more degrees to our terminal ray. So from here, I'm going to go around another full circle. And so if you go around another full circle, you'll notice that you started off with the 80 degrees, but you added another 360 degrees, okay? And by doing that, you'll find that the positive coterminal angle is then going to give you 440 degrees, okay? Now, looking the other way around, actually, let me just draw it again. I'm just going to draw it again here. Here's 80 degrees, okay? And now what we're going to do is, if we want the negative coterminal angle, then instead of going counterclockwise, adding degrees, we're then going to put ourselves in reverse and go the other way around. So you'll notice that my arrow is going clockwise now. It's going the other way around. And so what you'll notice is that if I started at 80, I'm backtracking, and then I'm even going back below that 0 degree mark. So I'm backtracking. I'm going to take the 80 degrees and go around another 360 degrees. I'm backtracking, so I'm going to have to minus 360 degrees. And therefore, you'll see we end up getting a negative angle measurement here. This is going to be negative 280 degrees. So that's going to be our negative coterminal angle. Okay. One thing to note here is that if it is a negative coterminal angle, notice that it definitely actually needs to be a negative value. If I've subtracted and I still get a positive number, that technically is not a negative coterminal angle. So you want to find the negative coterminal angle by making sure that this is a negative number for negative coterminal angles. Okay, let's do one more. Let's do the 50 degree, what is that, 40 minutes. Okay, so put that back. Okay, so 50 degrees, 40 minutes. So if we think about what that means, then again, we can draw the picture. 50 degrees and 40 minutes would be somewhere around here. I've gone 50 degrees, and then remember what 40 minutes means. You've gone a partial degree, so you're not quite at 51 degrees. 51 degrees might be like over here, right? But you just kind of took a little piece of that degree, and so what you're at is 50 degrees and 40 minutes. Okay, but what we want to do here is find the positive coterminal angle, and so we do that by adding a full circle around. So we're going to take our 50 degrees, 40 minutes, and add 360 full degrees, a full circle, a full revolution to that. And so 50 degrees, 40 minutes, if you do a little addition here, what you'll notice is, everything just kind of lines up. Addition is what it is. You just add them up, and you end up getting 410 degrees and 40 minutes. Okay, there we go. All right, now let's look at the second scenario, where we're again at 50 degrees, 40 minutes, but instead of finding the positive coterminal angle, we're going to find the negative coterminal angle, which means we backtrack, we go all the way around. Okay, so if we go all the way around, this one's a little bit trickier. It's not quite as simple as doing addition. What you'll notice here is that what we're essentially doing is subtracting 360 degrees. Okay, so if we do that, keep in mind just a basic principle. I'm going to bring you back to some prior knowledge. Okay, and I want you to think about how you generally do these things in terms of, let's say, some simpler numbers here. Let's say that we do, let's do 3.3 and minus a value of 6. Okay, now when you do 3.3 minus 6, imagine that this is like dollars, right? Let's say you have $3.30, but then you had to pay someone $6. Well, what ended up with that money, right? Where did that money go? So how much do you really owe that person? That's what you want to find out. So think about it like that. When you do 3.3 minus 6, here's often what I end up seeing a lot of students do in the very beginning. They say 3.3 minus 6. Oh, okay, I know that the 3 minus 6 is going to be a negative 3. And so I have a negative 3.3. Okay? This is far from the actual correct answer. This is not how we actually do subtraction. If you remember doing subtraction back in elementary school, you know that you really wanted to take your bigger number minus the smaller number. And you know that because the negative is associated with the bigger number, you know that in the end, you're going to end up with a negative value. But how do you really subtract 6 minus 3.3? Well, you need placeholders for the first part, right? And then secondly, don't forget that not only do you have to have those placeholders, you need those placeholders so that you can actually borrow. So if you're doing 6 minus 3.3, you're technically saying that the 6 turns into a 5, and the 0 is really like saying that you have the 10 tenths, basically, right? And so when you subtract them, the 10 minus the 3 is what's going to give you a 7, and then the 5 minus 3 is what's going to give you a 2. So 3.3 minus 6 is really like a value of negative 2.7. It's not the value of negative 3.3 as we said earlier. As you can see, it's not the same number. Okay, so similarly, when it comes to doing the coterminal angle for partial degrees, you need to keep this in mind, that what we're trying to do here is you've got the 50 degrees, 40 minutes, and you want to subtract 360 degrees. Remember what we just talked about in terms of how you can actually subtract those numbers though, right? So remember, because you're taking a small number minus a large number, think about, what you're really doing is, that your number is going to be finally a negative number, but you're really doing the big number minus small, like this. And then the idea here is you need to think about how you can actually take away and borrow at the same time. So when we do 360 degrees minus 50 degrees 40 minutes, how exactly do we borrow? Well, from the previous video, one thing that we had discussed was how we know that technically 1 degree is the same as 60 minutes. And so if we do that conversion, then we can say, let's borrow a degree. So we'll know that we now have 359 degrees, right? So 1 degree is borrowed. And what does that 1 degree turn into? That 1 degree is the same as 60 minutes. And so when we do the subtraction now, we can actually say, oh, 60 minutes minus 40 minutes, that'll give us 20 minutes left over. And then 359 degrees minus 50 degrees, that'll give us 309 degrees. But don't forget that you were subtracting a much larger number, so your value should be a negative number. Okay? So our negative coterminal angle is therefore going to be negative 309 degrees, 20 minutes. Okay? And that'll do it for this video, talking about terminal angles and coterminal angles.